in the conference will be recorded.
Yes.
And will be made available in our official website, right?
Yes, yes, it is. And there will be 3 links. Some of the I have already activated all the links, so I can see some of them are in the different link. Maybe they are preparing their presentation. Maybe they are very anxious about their presentation, how they will go. That's good. So, Professor Reza, nice to see you.
Hi, Harun. So glad to see you. Very funny and happy face. Very good. I'm sure that you did a lot of job to organize this conference. It's the first time we have such a big conference online. Yes, I know you gained a lot of experience. Anyway, true. The last day of the conference, probably you may have some time to share with us what you gained. So it is good for us for the future.
No problem at all.
Sure.
I'll be in your service.
Sure. Thank you.
All looking okay?
Hello, Professor Philos.
Hey, how are you?
We are fine. We are about to start in a few minutes.
The final moment come.
The reckoning.
Yeah. Hi, Professor Reza. Hi, Professor Ingai. How are you?
Hello, Professor Alam. How are you? Good to see you.
Yes, and sit my big here. Long here as well.
So right now I'm operating like 3 computers as 3 rooms.
So 3 in 1.
No, 3 computers separately because you need 3 like a station.
Okay.
3 workstation.
I think the biggest difficulty is for Professor Katerina, because she is very, I think, in the middle of the night.
Yeah, hello everybody.
Hi Katerina, how are you?
Yeah, how are you? Thank you.
It's nice
I'm
to
great.
see you. Sorry, we'll
Nice
give
to
you
see
extra hassle in the middle of the night.
Yeah, it's okay. It's 3 a.m. here. Early morning for me in Slovakia.
Yeah, but it's
So
just too early.
many greetings for everybody. Yeah.
really morning.
Yeah,
Yes.
yeah.
Now thank you for your participation at this moment. But we are like different parts of the world. We are going to connect together in a like a common spot, like common time. So we selected like based of our most of the participants who will be joining from Thailand, because Thailand is the host institute this time. So as a result of this Thailand location and his number of participants, we selected Thailand as our base time. So please adjust your time. It's only for a few days, like only 3 days, and we selected only like a 5 hours window in the 24 hours, like in a day, so that it's not a pressure for us, anybody to like to continue for 8 hours. Normally, our regular session, we previous conference we organized like starting from the big, starting from a day until like 6 o'clock or 5 o'clock. So considering this, like a time zone and all those, like different parameters with this conference organization, we have selected this 5 hours window so that everybody has a little bit of like flexibility and some comfort of their presentation and joining in the conference. But I really appreciate your time to join with this our host timeline, like Thailand time, because Professor Katrina, she is from like a middle of the Europe. So, and we are in the behind in Australia right now. Our time, local time, is 1 o'clock in the PM. So it's a huge time difference. Yes.
Yeah, of course, it's normal.
Okay, thank you very much.
Yeah.
Okay, everyone. I think if we are about time to start, it's 9 o'clock here in Thailand. So I wish to start officially, please.
Yes, please.
Okay. Good morning from Thailand, and from our friend all over the world. The third international conference on energy and power. This time is organized online platform, and it's organized by Chiang Mai University in Thailand, our friend Zhejiang University in China, with Australian Society of Energy and Power, with the General Chair, Professor Firoz Alam, and the Secretary, Dr. Harun Chowdhury. And with current COVID-19 pandemic situation, so we would like to have it a go at it, and we have full support from you all. We have about almost 140 submissions, and eventually we have something like 90 papers presented here. So all the support from Australia, Thailand, China, India, Bangladesh, Japan, South Korea, Malaysia, USA, UK, Germany, and Slovakia. So this is a very big and cozy community for us. And hopefully the conference will give you, the participant and the speaker, opportunity to find out about the new technology and learn about things that are of interest, insights and application from energy and power topic. Okay, and I would like to take this opportunity to welcome you all. And I think we could start with our first plenary speaker, Dr. Thavarat Sutabut. But before he starts, my co-chair, Dr. Chachawan Chaichana would introduce his brief bio.
Yes, morning everyone. My name is Chachawan, and it's my honor to present you Dr. Thavarat Sutabut. He's currently Chief Inspector General at the Ministry of Energy of Thailand since October 2018. And Dr. Thavarat has been involved in the energy sector for a long time since I know him, probably almost 20 years. And his work both are in energy efficiencies and also renewable energy. He's mainly a man of corporations. He connects people from wide range of areas and work with so many people. I think today his lecture will give you some very important highlights about Thailand's situations on energy sectors and also related sector. So I would like to take this opportunity to give the floor to Dr. Tawarat. Thank you very much.
ขอบคุณครับ สวัสดีครับ Thank you for your kind words, Dr. Chachwan, and also ขอบคุณครับ for Dr. Nakorn for your organization, and thank you very much for every organizing committee. I also thanks to the Chiang Mai University and Zhejiang University of China, and also Australia Energy and Power Associations for organizing this very timely virtual conference on International Conference on Energy and Power. And I'm glad that Thailand has an honor to be a host, but hopefully within a couple of years that we can meet again in physical manner. And I do believe that face-to-face meeting is much more effective. Okay, well, today I would like just to take a few minutes to present to you the latest versions of Thailand policy, touch a little bit on energy transitions, in which we'll give you an idea that Thailand is very serious about transition ourselves from the fossil fuel-based economy into the clean energy-based economy in the future. Okay, my slide would take about probably 15 minutes. There's a few slides, but I would like to present the following. Next slide, please. I have 4 agendas to brief you on what is happening in Thailand. Obviously, we plan to take more renewable energy into our system, both on renewable energy power and biofuels. And there are some talk about hydrogen, but that's a little bit further away. The second point is we are on the process of upgrading or modernizing our power system to have the more flexible ability to take up more renewables energy and the variation demand from the electric vehicle in the future. And thirdly, this is probably the most important point, that Thailand is very focused and very serious about doing a power trading on a cross-border trading, a physical electron to be traded. And also we are on the process, not on the process, we already done this, that we plan to promote more of renewable energy certificate, and we welcome both investor from international and domestic to participate in this REC scheme. And last but not least, we have done a few sandbox project in which we'll promote what we call the behind the meter concept, and that would be the enabling policy for such a smart city that would create some part of our city to be purely powered by renewables energy, and also enabling the smart technology within that parameters. Chiang Mai University is one of that prime example. Last but not least, my fourth point is our immediate future, that Thailand is very proactive in formulating the electric vehicle policy. We will have a series of supporting policy to make sure that Thailand will maintain our status as the Detroit of Asia, as the hub of automobiles, either is an ICE or electric vehicle. Next slide, please. But first of all, I would like just to brief you a bit about Thailand energy situations. At the moment, we are the economy of about 2 million oil equivalent barrel of oil equivalent per day as oil consumptions. But in terms of electricity, we consume about 190,000 gigawatt hours of power last year. We have installed capacity of about 49,000 megawatts, but our peak demand is only reached at the point of 30,000 megawatts. The peak demand has been somewhat stagnant in the past 3 years. The past 2 years the demand was evaporated due to the COVID, and we are one of the country that has been hit hardest due to COVID. All the border shut down, there is no tourists, the economic activities are evaporated. Bangkok has been silenced. There is no traffic in the past 2 years, but right now things start to picking up. And as a result, you can see from my next slide, please. You can see the results that we have accumulated the excessive reserve margin in our power system. At the moment, we accumulate the power almost 50% now. So that means we have more than enough power plants. So we plan to phase out coal plant quickly, and we plan to engage in buys and sell electricity cross-border. So that would give some idea of what is happening in the next few years in Thailand. Next slide, please. So my 4-point energy transition agenda in Thailand will be this. First, next slide, please. There will be more renewables energy. We already have a plan that the total capacity of renewable energy would accumulate to the level of about 29,000 megawatts by 2037, and that would take about 20% of the power demand in the system. But I think this plan is under revision, and I don't have the final number yet, but it plans to elevate or double up from 20% to almost 50% renewables energy in a longer term. Next slide, please. And renewables energy would come from many shape and form, but the most exciting one is the floating solar. Because we, as agriculture country, we have many reservoirs and dams, and the Electricity Generating Authority of Thailand, or EGAT, already take the lead in this field to use its own reservoir and build the giant floating solar farms in northeastern part of Thailand, and using the existing infrastructure to take up that power and feed the vicinity area with the pure renewables energy. And we also plan to improve the control system to make sure that all the variable renewables energy, such as solar and wind, could be coped up with the infrastructure that we have, including the mega battery storage system that is a grid type. Right now, we are building 2 of them. The size is probably 30 megawatt hours size. Next slide, please. Also, as I mentioned to you, that we are very focused on the grid scale battery system, and also we would increase more pump storage, and also we would like to turn our existing power plant fleet equipped with the digital technology to make sure that all the power plants are ready to serve in any case of emergency. And last but not least, we plan to integrate the embedded micro smart grid into the system. Next slide, please. The third point that I would like to present to you today is about power trading. Next slide, please. Thailand is very famous already for its geographic location in the heart of Southeast Asia. We have a good infrastructure that can take buys and sells electricity with our neighboring country, either on the high voltage format or a low voltage one. The latest development is to take the power from Laos PDR and transit all the way through Malaysia, all the way to Singapore. And recently I saw that Singapore is soliciting renewable energy power from international. I do hope that Thailand will participate on this. Next slide, please. And not only that we will trade the physical electron of the electricity, but right now we are doing what we call the Renewable Energy Certificate or REC. That one REC would equivalent to 1 megawatt hour of power of renewable power, and we plan to enlarge this policy to make sure that we can earn credits, or we can find investor who would like to take up the credit that already began. Recently, the ICEP, who already installed a lot of renewables energy power in the system, has sold some of the REC that they have to some of the Nordic company. Next slide, please. Last but not least, I would like to touch a little bit on the new policy to promote electric vehicles in Thailand. Next slide, please. We have what we call the 30-30 vision, or we would like to produce at least 30% of our car productions as the electrical one by 2030. As you may know, that Thailand is one of the major hub on a global scale producing automobiles. We are at the base of productions of 2 million cars per year. So by 2030, that we believe that there will be 50% of new car that sells as electrical one, and 30% of our productions is electric vehicle. And also this is applied for both four-wheelers or a normal car and the two-wheeler or motorcycles as well. The target as a number, the target as a number is this: we plan to have the production rate of 725,000,000 units of electric vehicle that could be produced in our country. 400 of them would be focused on the local market, and the 300 would be export oriented. And we hope that there will be more appetite for gigafactory battery scale. So we do believe by 2030, Thailand would be a country with a demand for at least 40 gigawatt hour battery per year. That would mean at least 4 or 5 gigaplant in our country. Next slide, please. And that would make us to remain in the top 10 or top 11 production hub globally as the automobile production facility. Next slide, please. This is the latest version of the electric vehicle policy. This is just a draft, but basically what we plan to produce is to have the some kind of the subsidy at sales price up to about $5,000 per unit, or in Thai 200,000 baht, for a car to make sure that it stimulates more demand, and the demand would bring in investment from foreign direct investment. We also plan to promote the two-wheelers or motorcycle. That would be, again, the demand subsidy, a demand-linked subsidy, approximately about $600 per unit. And there are some conditions, though, that if in the first few years there is no production line coming up yet, we would allow some importations tax-free, but condition is you have to produce the unit locally thereafter at the same amount. Also, there will be some kind of the subsidy for battery. That again, it will be a demand-linked subsidy. Right now, we are planning for about $20 per kilowatt hours to a battery that locally produced. That is about 25% reduction comparing to the production cost structure from China. Also, we plan, but this is not yet crystallized, on subsidy on the charging station as well. That would be either the CapEx or investment grant, or a reduced discount, a deep discount price of electricity from a normal of 10 cents per kilowatt hour to only 0.9 cents. So that would be let the investor on the charging stations to have a quicker cost recovery process. And we plan to also create what we call a captive demand that turns the government and state-owned enterprise fleets of cars and trucks into the electrical one. Right now, the candidate from the government fleets is about 100,000 units in the next 3 years. So this is the big picture of how Thailand can turn ourselves into the mainstream of energy transition. Next slide, please. And that would bring a lot of attention to the world that Thailand is very serious to bring in more investment and would like to be on the mainstream of energy transitions in Thailand. And this is my last slide. Thank you very much. ขอบคุณครับ
Thank you, Dr. Tawarat, for the information. So we have plenty of time for discussion. Any question? Maybe I wish to start. Dr. Tawarat, from the COP26 in Glasgow, is there anything interesting for Thailand?
Yes.
Yes, please.
Yes. Well, our Prime Minister took opportunity at the COP26 to announce our firm commitment. I think there's a few number. I think he announced that Thailand will become carbon neutral economy by 2050. And later on by 2065, we will become a net zero country. And the assumption is our peak year would be 2030. And again, within all this commitment, the energy transition is the major role or major policy on this, which include the electric vehicles and, uptaking the renewable energy into the system. And that's what the Prime Minister announced 2 weeks ago.
Any question from the floor?
Yes, I have a small question to Dr.
Please go ahead, Professor Filas Alam.
Dr. Tawarat, in your presentation, you mentioned that 12% power is currently Thailand is importing. It is from which country you are getting that import? A single country or multiple countries? Thank you.
Thank you, Professor Filas. Right now, we import about 8 to 10% of our electricity from neighboring country. Right now, we only imported from one country, from Laos PDR. But also we have the what we call the exchange contract with Malaysia. Exchange would mean in terms of emergency, we can take their power, or in case of their emergency, they can take our power. But for importation, mainly from Laos PDR, we import from probably 8 or 9 projects. The total capacity of that is about 6,000 megawatts.
And it is the hydro.
Most of them are hydro. There's one coal power plant.
Thank you. Thank you very much.
You're welcome.
Can I ask a question?
Please go ahead.
Thanks. Dr. Sutabor, you have mentioned briefly about hydrogen. So what sort of, in lots of discussion going on, and what's the status and current thinking around hydrogen in Thailand?
Yes, thank you, Khun Nashat. I think the hydrogens in Thailand is this. There's two underlying fundamental. First, since we have excess electricity, and some of them are not cheap electricity, we probably plan to turn that cheap excess electricity into hydrogen, such as there is one wind farm that I know of, turn and use the excess electricity and produce hydrogen. And on the second underlying is we are hoping, or we are looking forward to an application of mixing hydrogen with natural gas, because Thailand has a big fleet of gas-fired combined cycle power plants, in which is too young to retire, but we would like to reduce the carbon footprint from this power plant. So we need hydrogen to mix them up. So that's the plan. But right now there is no firm pilot project as yet. Most of them are just research. And there are some talk with Australia and Japan and trying to, ask us to import hydrogen from them, but that is too far away. That's too far away. That's my take.
So I have, and this is Somnath Chattopadhyay from India. I have one more question, that Thailand is an oceanic country. So what is Thailand's plan for wind power and tidal power and solar? Now we are having some units. It will be the top part, it will be capturing the solar energy. The middle part will capturing the wind energy, and the bottom part will capture the tidal energy. So these hybrid, these kind of strategies, whether Thailand has some plan to implement in near future. That is my question.
Thank you, Professor Somnath. I think Thailand is very focused on solar energy. We have some wind resources, but it's not enough. Wind resources is not enough. However, I have to admit that we don't have enough research to do any conclusion on our offshore wind potential. There are some school of thought that there might be some kind of a big offshore wind potential similar to what Vietnam has, but there is no enough research to make any conclusions. But onshore wind, there's a limited space that is suitable for such a big farm. But for solar energy, I think we are very progressive on this. And you mentioned the tidal energy. Again, we used to have some research project on the tidal and the wave energy, but the conclusion from that research is it's very location sensitive, and it's not big enough to promote into investment type of project. But again, I do welcome any suggestion if there is any research, more research project need to be done to make sure that we can harvest every type of renewables energy in our country. Thank you.
Thank you.
Is there any question, please? Maybe I can chip in now. From the COP26, that is one of my interests. Dr. Tawarat, at the end of COP26 in Glasgow, the delegate talking about phasing down coal. What is that the implication for Thailand from your view, please?
Yes, we will accelerate our phasing out coal plan. From previously, we thought that coal would give us some balancing act because we have a lot of gas in the system. So we need to diversify, and coal is one of the projected diverse field. But right now, I think the mindset at the leadership of my ministry changed a bit, that we probably don't need coal to balance the act to diversify our fuel mix. So we probably retire coal plants earlier than planned, and probably I think there is only one possible new coal plant would come into the system, but it is a replacement of the old plant. And then that's it. There will be no more coal for Thailand after 2030.
Thank you. Is there any more discussion or question from the floor, please?
Well, if you have more questions, it's okay to email me. Dr. Nakorn and Dr. Chachawan has my email address. So if there is any further questions, I can entertain all your questions. Thank you very much.
Okay, if there is no further question, please give applause.
Thank you. Yes,
to
yes.
Dr. Taras,
Yes,
our
yes,
plenary
yes.
speak.
Thank you very much.
Nice.
This very quickly conclude our first plenary session, and for the normal conference session 1, 2, and 3 will start according to plan at 10 o'clock, I think. Dr. Harun, can you confirm, please?
You are on mute, Dr. Harun.
Oh, yes, everything is under control. So you can log into your respective link, and what I suggest that still we have some time left, but you should join in at least 10 minutes before, or 5 minutes, at least 10 minutes before would be good, to your respective session. And session chairs and co-chairs, they will be also do some marking on the presentation, and we are going to announce the best presenter at the end of the conference. So this is our student, especially to encourage them to produce good result and quality research in future. So this is our effort, and our session chair and also co-chair, they will be helping with this our marking activities. And there will be a strict timeline because we need to finish our session in time. So I request our all session judges, chairs and co-chairs to maintain the time, please, because we just need to finish the time. So timeline we have set for our keynote speaker, because there will be keynote speakers at the beginning of the session, and their presentation will be half an hour, and then after that there will be our speaker, like a researcher and student speaker. So we also will be marking their one. So we have to strictly follow the timelines, and once we are not presenting, so what we'll do, that will be silent, or I can see everybody's following the rule. That is really good. That
Maybe we could take some photo.
Yeah.
This
So
first session.
oh yes.
Maybe
So
we could
that would
ask
be,
everyone to switch on.
oh,
Switch
that
on
would be
the
good.
video,
Yeah.
please.
So we'll be like a gallery view, and we'll take some photo.
Good photo for PR.
Yeah, and what I already mentioned, that we have our recordings on, so everything will be recorded, and we'll share the link so that anybody can view, after it's done. So we're going to take some photos, and
I think we can request Dr. Thorat, if he's available, to join in the photo session.
okay, that's good.
Professor Macron, you see whether he's available or not, because he's a busy man.
Okay, everyone on.
Hey, Dr. Harun,
Yes.
did you mention to all the presenter that they will have to present up to 10 minutes and then 5 minutes for the question? Has that
Yes,
been complete?
Yes, I did. But again, you mentioned it. It's thank you for that. So our presenter, they have only 10 minutes presentation, and then there'll be some questions, question time from the audience, and from the judges, and there'll be a changeover. So once we are changing over, so the next presenter should be ready for their presentation slide. So thank you.
And maybe I wish to add some presentation will be presenting live, and some would be from the from sharing the video clip of presentation, I think.
Oh yeah, that's true. So some of the presentation they have already sent us the presentations recorded, and during their presentation slot, we will play on behalf of the presenter.
Dr. Harun, just another question. In the table, when there are separate sessions, 3 different color, right? That blue, sorry, the green and red and black, right?
Yeah. So yeah.
So, but I think, look, I can, in my screen, I can see the black and red. Is there also green color by any chance? Which papers are, if you have a look and confirm everyone that depending on the color, and they can choose which session they're going.
Yeah, so I just it's like in the master plan, if you see the program that is published on our website, and they can just follow this, the link, and that would be, I think, would be, like a if there is any, do you understand, or if there is any confusion, just let me know.
That's fine. I think I was just saying that the color I can see black and red, so not green. So maybe check in the website. The website I'm just refreshed now, so that everybody gets that one.
Oh yeah, I understand your point. Yeah, I can edit that one. Okay, yeah, no problem.
Yeah, I think Naushad is not the color, so you need to like see the master plan from the website. So this is the one actually.
Yeah.
The green,
So
all greens are the papers that are going to
yes,
present.
yes, perfectly. Dr. Naushad is emphasizing that green is a very important color for an energy conference. That Dr. Hawk is just presenting.
Thank you, Professor.
No, that's true. Yeah, Dr. Naushad, yeah, because you are right that there will be 3 rooms, and then if someone is I try to make it a color coded so that they can easily identify their room, like which link they are going to like click. But eventually all the rooms are they'll be like open to everybody. So if someone is interested to someone's presentation, he can join the session by just like get like closing the link and then open the respected link. So it is flexible for anybody to join any session. So we keep everything open for our participant.
Thank you.
Yeah, Harun,
Yeah, I think you need to follow the website. It is very detailed, not the email. Email is a partial information there. So if you look at the website, you can see in color code and also session, very detailed everything there. So and also which session to click, you just click, that's all. Right.
Yeah.
So we need to see that one. And I think every one of you, and also you can see their individual paper ID and the time. So all information is there. So if you get from email, then you cannot get all information at the same time together. So it is better to look at the website. Maybe you can keep that website in your disposal and then just click and go. And I think that will be the easiest way. Now, I think before we go for next session, Professor Macron and Dr. Harun, you wanted to have a picture of us. So have you taken our picture or not yet?
I have, like, because I'm capturing a whole video, so I can take any.
Yeah, no, take a still picture because that is better from here.
Yeah, just a minute. I'm just going to take some of our.
Yeah,
So in
Harun,
the process, I again want to thank all the organizers, at least in the first session. There's a terrific work because it is not easy to organize an online conference and all sorts of things. The links are working, the entire organization structured, no confusion. I'm really amazed about the synchronous activity. It is done from the different parts of the world, especially in Thailand and then Australia, then other parts of the world. It is terrific. Though this has to be said at the end of the conference, but in the session, I'm still amazed about the technological implementation, what is going on for those. And I can tell you from my side, absolutely no confusion, totally crystal clear, and amazed how the things are done. Hats off to Dr. Harun, Professor Firoz, Professor Markan, and all sorts of people.
Professor Macron, he and Dr. Harun, they are the two people who did everything. We just, come and see, and that's all. But the actual work being done by Professor Macron and Dr. Harun. These are the two people single-handedly everything organized. So thank you very, very much from the bottom of our hearts.
Okay, and I have another question, Harun.
Yes.
That you said that some of them, they have sent their recorded video for presentation, and you said that we'll play that one. We means who is going to play that video? Is the session chair or someone like you, or who? Because I don't have access to that, like the video thing.
Oh, yeah, video. Yes. Thank you for your information. You're really, keen to the point. So thank you for your question, and to give you the video link. So I'll share the video link because we have our official YouTube channel for ASEP. And what we did, I already uploaded all the videos, and the the playlist are available there, and with their number, name, and the titles are also easily visible. So anybody can access to the internet like YouTube. They can access this their information like presentation, and all those are on YouTube channel.
Where is that YouTube link in the?
Okay, I'm going to share it soon right now.
Yeah, just share the screen so that we can see.
Yeah, I think it will be better if you tell the session chair which particular presentation is on YouTube, then they can check that one there.
Yeah, so I already marked. Yeah, that's a good question. I already marked their presentation, what are recorded and I'm going to show you a little bit of my screen.
I think there would be not a lot, only few, I think.
Hello, my name is Deshaton Shewon. I am from Mojo University.
Okay, so this one is the so I posted in the group chat. So the link is there. I also post the link in there. So if I click on the link.
Yeah, I think you open the website. And
yeah. I'm going to share my screen so that you can see. So here is the link. I already submitted the link to our group chat in this Zoom link. And this is the link. If you open this one, the link, and these are the playlist there. And this is our website, and all the presentation are in there. So the link, if you get the link, for example, this particular paper. So this is our third ICEP 2001, and then this is the number of the ID. So ID is 36, for example. And if you go to our website, you see this one, 32. So 32, this is the 32 number. So it is marked as red. So that one is recorded. And 111, that is recorded. So we have the list, and the recordings are available here. So you can get from the the playlist. So playlist will be one after another. So playlist will be available there. And it's better to just take this as a reference of our like planning. So this will give us all the information, who will be presenting, when and which link they will be using, and the timeline. And timeline, again, I'm telling you, this timeline is for Thailand local time. So now we are going to, for example, number 4. Number 4 is recorded because this one is marked as red. So number 4, the link, I will also put a link there so that you can, you don't need to look for the link for anywhere. The link will be available after the table. So this link, I'm going to paste these links in a minute. It will be available here. You click on the link, you will get it.
I think that will be good. That will be good. Yes. And then session chair also can see that which paper is recorded, and they can direct it. They can direct the participants to watch during that time using the link. Yes, you just put that number. So for example, 4 and then link 45 link. I like that.
I just have shared the YouTube channel. So all the recordings are there. So based on the number, it can be sort of played during the session, I think. Yeah.
Yeah, okay. Thank you, Ashfaq. I think it's very useful, at least to me. That I just copied the link and put it under the browser.
For your convenience, I will just publish this link there, so you can just click up a button.
Yeah, publish it. It's very important.
Yeah, I'll just publish this link, and it will be available to anybody. Yeah. So that's a good question. Like, thank you, Professor Rasul, for these, tips, or just draw our attention there. It's good for our management. Any other issues like we can look into the matter?
I think in the meantime, during the conference, if there is any housekeeping to do, any question, you can contact us directly, either me or Dr. Harun, and then we will try to address it very quickly as we can.
Okay, thank you. Yes. So if there is any other issues or any question or anything, immediately just let me know. I will just take care, with my all effort.
And I think for the next session is starting at 10, so people have like something like 10 or 15 minutes to prepare.
Yeah, I think they can now join there.
Yeah, we should leave this session now, and then let the people prepare for official session 1, 2, and 3 going to start at 10 o'clock.
So this
thank you everyone for joining us.
Yeah, so
close this sharing.
Yeah, so before we just leave, I just let us. This is our link 1, and link 2 will be another one. Who are in charge of the link 1? So stay here. And link 2, just click on the link 2, and they'll be join that link 2, and link 3. But look at the master our table. So this table will give us all the indication where to go. So links are all there, and information, everything is all there, all in one page. So you should just follow this one, and hopefully it will be helpful. Okay, Macron. That's, I think, we can.
You unshare your screen.
Oh, yeah.
Okay.
All right.
Thank you, you all. I'm gonna leave the session and I'm gonna roaming around session 2 and 3 as well. I'll see you all later.
Okay.
People, those who are in session 1, they can take over it now.
Yeah, session 1 can stay here.
So the session 1 chair is Professor Ingai Jin, and also co-chair, I think, Dr. Ashfaq Chaudhary. Ashfaq, are you here? I saw him somewhere. Okay,
Yeah,
so
Ashfaq attended, so he should be.
yeah, I
around.
saw him. I think he most probably went for tea or something, because we don't have a tea break.
Yeah,
So he went for tea.
could be, yeah.
All right. So Ingai, you please prepare your things so you know how many. I think your first keynote speaker is Professor Katerina Monkova, I believe.
Yes, I know.
Okay, Professor Katerina, she's already there. So and you can talk a little bit about her because the information we have already keynote speaker, a short biography in the website. So I think you don't need to read all of them, but just major things, because all of these people are very well known. So it will be anyway. If we say something, it will not be all enough, but at least need to say that their main things, main activities. That's all. And Professor Ingai, she herself also a keynote speaker later on.
So we have a very good female representation. We have a gender balanced conference.
I think that is a
absolutely great.
Very pleasing thing. Very pleasing that we have a good number of our keynote speakers are female, but from the opposite gender. Okay, opposite gender is not a negative or positive way. So it is a really good thing. I really feel very proud that we managed to have their consent and their willingness to participate in this conference with their whole heart. And we are very pleased and very honored by their participation. Okay, we have also 2 keynote speakers from, actually 3 keynote speakers, female keynote speakers from People's Republic of China, and then 1 female we have from Slovak Republic, and then also another female
from Japan.
From Japan. So this is really good, and in the future we want to see even more. Thank you. So I leave it with Ingai's hand, and so you are now the boss.
Yeah, Professor Firoz, I think you should send us a tea voucher, because this is a tea time and we don't have money to buy the tea. So give us a tea voucher. We cannot hear, you're on mute.
So in a paperless environment, maybe a voucherless tea, that is also possible.
Yeah.
Yeah, I think
Anyway, this time Harun is fine. Firoz is okay, no problem. But next time we should have that lunch or tea voucher. Otherwise, we cannot do the session chair or we cannot do the presentation.
Yeah, I think, look, the conference, one of the biggest important thing is having tea, coffee, conversation, meet each other, introduce each other, know each other. And that is the things we are missing. The main purpose of a conference is to develop a network, develop a friendship. And that is the really missing part. Only to attend online one session or two sessions, friendship doesn't develop that way. So it is always things. But COVID-19 changed our life, but we hope that we can come back to that normal system very soon. And we hope that in our next conferences, we'll definitely have a face-to-face main part of the conference. So we all look forward to your warm tea, hot and cold food during the lunch time, and afternoon tea, and also conference dinner in the future.
Professor Rasul is just aligned with the Indian government policy, food for work. So sharing work, you need food.
Yeah, no, that's true. So anyway, I think this is fine. This time it's a COVID. We don't have that much, I think, capacity to all this thing. So next time we should be able to do face-to-face.
Good morning, professors. My name is Ying Aijin. I'm from Jilin University.
Okay, that's good. So you will remain in this session, isn't it?
Yes.
Okay, I'll have to switch from session 1 to session 2 now.
Yes, Professor Ingai Jain from Jilin University, she will be the chairing the session, along with Dr. Ashfaq Chaudhary. I'm not sure where is he. Oh, he'll be joining soon.
Yeah, I'm here.
Oh, he's there. Huh? Okay. We are looking for the young man, and we can't find him. Find him, and I told that I saw him.
I was hiding.
And then I told everyone that you went for tea.
Professor Firoz is not comfortable with the older people. That is why he is looking for you.
No, look, I think
I'm just joking.
It's a pleasant thing with all these people as a team together. It always works very nice. It always works very nice. Okay, all right. I live in peace. I don't want to talk, because if we talk, then they will not be able to do their work. No.
Okay, I have to leave and join session 2. So see you this time.
See you. Dr. Ashvik, nice to see you.
Yeah, nice to see you.
So the session one will start in about 2 minutes.
Oh, all right, excellent. Thanks. Yeah.
Can we get started now? Professor Katerina Monkova.
Yeah. Could you hear me?
Yes.
Thank you.
We will have keynote one speaker from Technical University of Košice, Slovak Republic, Professor Katerina Monkova. Welcome.
Thank you. Good morning or hello, everyone. Could you see my presentation, please?
Yes.
Good
Yes,
morning,
okay.
Professor Monkova.
Thank you very much for coming to the conference. It's my pleasure to be here with everybody. So let me introduce myself first. Again, my name is Katarina Monkova. I'm a lecturer at Technical University of Košice at Faculty of Manufacturing Technologies with seat in Prešov in Slovakia. Our faculty is one of 9 faculties of Technical University of Košice. While Košice and Prešov are near cities, the distance between them is about 35 kilometers, and they are the second and the third biggest cities in Slovakia after the capital city Bratislava. About 700 students study at our faculty. I would like to talk today about basic research steps that were done at a comprehensive research of a newly designed axial bearing, and co-author of this research is Marek Urbanov. Several words about the plane bearings. They are one of the main parts of the power machines, such as turbines and compressors. However, there are many cases when in large power equipment is occurring asymmetrical loading on bearings due to thermal deformations, production inaccuracies, or simple deflection of the shaft. Over the last few years, thanks to increasingly precise manufacturing, solutions that can eliminate this phenomenon have been developed, and so-called self-acquiescing bearing has been started to be used. At least 2 elements are required for the slide bearing, and they are the bearing itself and the rotor collar. But usually self-acquiescing thrust bed bearing consists of following basic parts, as you can see on the figure on the left. It's a bearing body or so-called housing, thrust bed, self-acquiescing element, and name also lever, just next nozzle, and floating pressure element. For every thrust bed, it is necessary to use 2 levers. It means that, for example, at 18 pets bearing, it is necessary to use 36 levers. In the case of the thrust bearing, the most critical part is a system of very precise manufactured levers, which are in the close contacts each to other, so they have to be only properly designed from the geometrical point of view, but they had to be important role also plays the quality of the functional surfaces of this lever. You can see such a bearing with a system of levers that has been designed by authors in the pictures in the middle of the slide, with one element and work surface on the bottom of the slide. The aim of the set of the lever is to distribute the load evenly over the entire circumference of the bearing. The evenly distributed load is then transferred to the bearing housing and subsequently to the machine frame, of course. The lever system must be designed and manufactured so that it is capable of transferring the pressure on the lower part of the bearing to the upper part of the bearing. In the pictures, you can see the acting forces and their distribution, and at the bottom of the slide is presented the principle of the lever tilting, while on the left side, it is without the shaft deflection, and on the right side, or in the middle, is the situation when the misalignment occurs. Due to the different mergers between global bearing producers in recent years, there are currently only 3 major global suppliers that produce these bearings as standard. That means that not a special project. Each of these manufacturers, of course, uses to a greater or lesser degree different design and manufacturing technology. Many aspects had to be taken into account at self-acquiring bearing with axial tilting segments design, like material, geometry, technological conditions, surface integrity, and tribological properties, and others. So the first step was related to the decision in our research, was related to the decision what material should be considered as a designing. And the material has to have sufficient mechanical and tribological properties, taking into account also aspects of surface integrity. And there are several materials that could be used for this purpose. But one of the most commonly used material in the production of bearings, and which meets the requirements characteristics of a highly stressed functional component, is a chromium nickel molybdenum steel that was also selected as a material for the production of the newly developed bearing prototype. It was done based on the previous review and other research that the company producing this type of bearings deal with. So I can introduce the basic steps of the presented research with the development of a new self-acquiring thrust bearing. And this research can be divided in 3 basic phases. They are the first, geometry design and development of a lever. The second, ensuring wear resistance of the lever surface. And the third one, verifying the functionality of the new thrust bearing in real operating conditions. That is also the basic line of my presentation. All 3 phases, of course, will be described in detail by the next slides. So, as for the first phase, within the first phase, a primary geometry of 3 basic variants of the lever was designed. So sorry, I'm skipped one. slide, so I'm back. So was designed and the prototypes were produced. And to specify which of the geometry is the most suitable, you can see the geometry on the top of the slide, all three variants. So to specify which of the geometry is the most suitable in terms of kinematic functionality of the bearing and which variant is the best for the next investigation, a simple experimental test was carried out. At the experiments, the measured bearing was divided into 4 quadrants, and gradually each quadrant was loaded. The measures were done firstly in a horizontal and then in a vertical position on the bearing, because the ability to load the bearing in vertical position is very important due to so-called lever drop effect. And functionality is limited due to this effect. In the figure on the left side, in the middle part of slide, the division of a bearing with 18 segments into 4 quadrants and position of dial indicators are shown. A plot on the right side shows trends in the force loads distribution under individual segments and measured at the lateral load of 70 kilonewtons and the central load of 100 kilonewtons. The maximum bearing deflection was also monitored, while a deviation value was read on the dial indicator. The best variant from the geometry and also measured deviation points of view was a third variant. So this type of lever design was selected for kinematic and a numerical analysis. You can see the path of individual levers during their motion in the picture right down that was generated based on the kinematic analysis. Okay, within the same first phase, but in the next step, the numerical analysis were done for 2 bearings using the software ANSYS based on selected geometry previously presented. They will be, these bearings will be referred in my presentation as a small and a large bearing in the first, while the basic diameters of bearings and basic sizes of the levers you can see on the slide. The model of self-equalizing system is cyclically symmetric. That means that 2 whole levers can be included in one symmetrical segment. For the analysis, therefore, it was chosen the part of the bearing where the symmetrical segment contains the entire lower lever arm and 2 halves of the upper lever arm, as it is shown in the figure right down. A load that acts on the bearing was set up based on the real values provided by GTW company, with which this research was done, that was measured in real practice. Based on that, the small bearing was loaded with an axial force of 128 kilonewtons and a large bearing with a force of 393 kilonewtons. The load has been evenly distributed on all segments and on of the bearing with the analysis. Also in the real practice, it can be slightly a little bit different, of course. Just it was used for the numerical analysis, these numbers of load. The boundary conditions of the analysis you can see in the slide, and they apply to prevent the movement of the system, and also due to the stress distribution in the levers was influenced as little as possible. So these conditions prevented radial displacement of the entire levers and their rotation around the central axis. Finding the right choices of contact parameters for a converging solution was not easy at all because the contacts are in series and both the upper and lower lever arms are loaded only through these contacts. So due to this, it was not possible to consider the values of stress in a closed area of contacts as reliable. So an analytical computation according to the Hertz theory was also used for the evaluation. So on the slide here, you can see examples of the results from numerical analysis. It was found that the distribution of vertical displacements, vertical stresses, and the reduced stresses have been similar at both studied bearings. So as for distribution, only the values were different. The reduced stresses, according to the HMH hypothesis, has maxima in the vicinity of the contacts and further in the mentioned corners of the lever arms. Since the chromium nickel molybdenum steel has been selected for the levers design, and with it has a yield strength of 900 megapascals in a refined state, so all the stress values could be considered as safe. Within the first phase also, after numerical analysis, the first prototypes of the real self-acquiring bearings were produced, and to verify their geometry, design, and functionality, they were also experimentally tested within a static comprehensive destructive test. The lever was positioned in the testing machine, and it was supported during the static tests on both sides of the hardened cylinders. Since the lever had a cylindrical shape on one side, left, and planar shape on the right side, as it is shown in the picture, both contact pairs, cylinder plane and cylinder-cylinder, could be statically tested at the same time. The measured dependencies of a force on the displacement you can see in the graph in the slide below, where the curves for 3 different sizes of bearings are shown that were produced in 2 variants, with and without the holes in the center of levers due to the assemblings. For safety reasons, the levers were tested only for a maximum load of 200 kilonewtons. The large type of levers returned to their original shape after the load was completed. That was verified on a granite plate. It means that the deformation of all levers took place in the area of elastic deformations. But for the small type of lever, plastic deformation already occurred at about 150 or 60 kilonewtons. Then the test was interrupted because the lever slipped up the jaws, a vertical line down in the graph in the figure. Small levers were not as rigid as larger variants, but if it is considered that the nominal load on the whole bearing where the small variant of levers is used is a maximum about 130 kilonewtons, which means that less 1 or 11 kilonewtons come out on one lever. It can then be stated that the safety static factor is used more than 10 times higher, and also small levers are sufficiently rigid. As was already said, yes, I checked, material of the levers has to possess sufficient mechanical and tribological properties. So taking into account also aspect of surface integrity is necessary. As it was already presented, the best design of lever has had 2 types of contact, cylinder-cylinder and cylinder plane. And based on that, a simplified version in the second phase of the research of the contact pairs were selected for the test, at which the influence of surface treatment and its ability to resist static load. The testing samples dimensions that you can read on the slide correlated with the size of a lever for a reference bearing with 18 pads. The reason for designing a simplified version of the samples was to increase the efficiency of the tests as the cost of the test, of course, but to achieve results corresponding to the real shape of the levers. The technological conditions of samples manufacturing are listed at the bottom of the slide. So all produced samples were heat treated due to the material structure reinforcement as a quenching in oil at about 850 degrees of Celsius and tempering during the same temperature range at about 650 degrees of Celsius. The samples were electrolyzed nickel plated and nitrided, where half of them was processed by tumbling, and the second part of samples remained only coated. At total, 108 pieces of samples have been produced, while 6 different feeds were used for the surface machining. In the table on the slide, you can see the characteristics of individual cylindrical samples. Similarly, it was at the plate samples. So the proposed static load experiments aim to compare the behavior of selected surface treatments and to monitor their response to static loads were done. Static load was carried out by hydraulic mechanism at time duration 10 seconds with 4 different loads. That means that 500 kilograms was selected as a nominal load, 1,000 kilograms corresponds to overloading, 2,000 kilograms was selected to check the high overloading, and 5 tons was employed to simulate an extreme overload at which the self-equalizing mechanism doesn't work, just to check it. Imprint evaluation was done employing Nikon stereo microscope, and the surface contact was evaluated by scanning microscope. In the picture at the bottom of the slide, you can see the examples of the imprints, documentations, and also surface treatment evaluation for contact pair cylinder-cylinder. It was similarly also documented at cylinder plate contacts for all pairs samples. Just to present and to see what was done. So within the same second phase, the dependencies of the wear on load force have been plotted. The examples of these dependencies for contact pair cylinder plane you can see on the top of the slide, and the measures were statistically processed, and from the average values, the histogram for all samples has been prepared to compare the wear at the individual surface treatments, and more easily that is presented on the bottom of the slide. It can be stated that the nitrided layer in the static test showed good results at lower loads up to 500 kilograms, when the traces were not practically measurable after impressions. This layer is very hard and resistant to load, but on the other hand, very brittle. Impressions with a load of 1,000 kilograms have already shown cracks visible by means of stereo microscope. For impressions with a load of 2 or 5 tons, large cracks are visible, which delimit the impression. In the case of nickel-plated samples, relatively low hardness and high plasticity of the layer was seen compared to the nitrided layers. The width of the form cracks have similar dimensions compared to the cracks formed in the uncoated samples, which were only refined. So after the geometry and surface treatment investigation, the real levels and self-acquiring bearings were produced and subjected to the final tests. The aim of the final experiments was to verify the overall functionality of the newly developed type of bearing. 3 different types of equipment were used within the research. The primary tests were carried out using the TG10 experimental turbine located in the Dosan Škoda Power Research Center. And in collaboration, we reach very nice results. This equipment is basically single stage turbine capable of rotating at speed of more than 10,000 revolutions per minute. And the turbine is equipped on one side with a combined plane bearing and on the other side with a radial bearing containing tilting segments. For testing, 8 segments axial bearing with levers on a pitch circle 336 millimeters was used for testing. And it can be seen from the graph left down on the bottom of the slide that the self-aligning mechanism in the bearing worked very well, even at full load, due to the fact that the measured temperatures in the lower and upper segments were almost the same. In absolute terms, the temperatures of both segments were well below the possible maximum, which is around 115 degrees of Celsius. The bearing was also equipped with sensor for measuring the magnitude of the axial force, so it was possible to measure the functionality of the mechanism from the point of view of the distribution of forces acting on the upper and lower segments. Also, in this case, the difference was insignificant. It can be stated, based on the results on this equipment, the design of the prototype completely fulfilled the requirement of the modularity of the combined bearing solution. So the second testing device was the experimental gear of the Czech companies Holden Czeka, it's difficult to pronounce, GKD compressors and GTW bearings. They are Czech companies. That is shown this device in the top right picture. In this experiment, functionality of 3 types of bearings were compared. The first one had a fixed profile. The second one, tilted pad bearing with 8 levers. And finally, the third one was a newly developed bearing with a self-acquiring system. The thermocouples were placed on the bearing elements according to the picture shown on the bottom right of the slide. And the function of the self-acquiring system was manifested in the uniformity of temperatures around the perimeter. When the maximum temperature difference of a newly developed bearing reached about 15 degrees of Celsius, in contrast to the fixed and conventional tilting pad bearing, bearings that achieved the differences 43 and 32 degrees of Celsius respectively. They are not presented in the slide because of not necessary to present it also similar diagrams. So it means that the new type of bearing with self-acquiring mechanism appears to be most suitable for use in centrifugal compressors or turbines. And the final experiment, the third experiment equipment used within the research was the experiment compressor, so-called Darina 4. a prototype of newly developed self-aligning bearing with 8 segments on a 115 millimeters pitch circle was used to be investigated for misalignment, employing the precisely ground planes with 3 different tilts. Measurements showed that at tilt of 0 degrees, the difference between the lowest and highest temperature of the segment was 9.3 degrees Celsius, and at tilt of 0 degrees, it was 11.6 degrees of Celsius, which means that the temperatures were very, very close. Despite of the fact that deflection limit for the bearing was designed to be 0.1 degree, the prototype of bearing managed the double misalignment without any problems. And because the temperature of the both segments were well below the possible maximum, which is around mentioned 115 degrees of Celsius, it is possible to suppose also that the prototype bearing would handle misalignment much greater than 0.2 degrees. So after this comprehensive research, it can be concluded. So presented research was focused on a long-term investigation aimed at design a new self-aligning thrust bearing, which is commonly used in the power machines, such as turbines and compressors. The chromium nickel molybdenum steel has been used for the levers design and production, and 3 variants of the levers geometry have been preliminarily tested in the first phase, designed and tested, and the 3rd variant as the most appropriate design of lever was selected for further investigation. Numerical analysis was performed for the 2 sizes of bearings and their corresponding levers. The real bearings with the needed number of elements were produced in the 3 sizes based on numerical analysis, and they were experimentally tested through static destructive test. The achieved results confirm the design of the levers, that geometry is sufficient and stiffness is fine for all the 3 types of levers, and good functionality and reliability was approved. So after that, nickel plating has been evaluated as the most suitable surface treatment from a wear resistant point of view in the 2nd phase of the research. And finally, the real operational functionality of the newly developed self-aligning thrust bearing was tested using 3 different devices. So the tested bearings have met all requirements, and currently they are successfully implemented in the real practice. So we are very happy with the results. So thank you for your attention. I am happy to be here with you. If any question, you are welcome, please. Thank you once more.
Thank you, Professor Katerina Monkova. Because we are out of time, if you have any questions, please type your questions in chat box, and we'll move on to next part. Thank you, Professor Monkova.
Thank you.
We welcome Mr. Panofong Mankid from Chiang Mai University to give a speech. Welcome.
Good morning,
everybody.
Okay, I will be happy. I'm happy to be here, and now I would like to sharing my screen.
Just would like to request Professor Monkova to stop sharing the screen so that the other presenter can share the screen. Thank you.
Okay, thank you. Sorry.
That's all right, no problem.
Can you hear? Can you see?
Yes, yes,
Yeah,
we
yes,
can see.
yes.
Yes.
Okay. I will start with my video recording and just a moment, please. Okay. Hello, everybody. My name is Panupong Mankit, and I'm a graduate student in Energy Engineering program, Chiang Mai University, Thailand. Today, I'm gonna talk about analysis of reaction kinetics for thermal degradation of heme residues. My presentation is divided into 4 parts. First, introduction. The next part is material and methods. The third part is result and discussion. And finally, I will provide you the conclusion of this work. The demand and consumption of world energy remain high even when the COVID-19 pandemic is ongoing. Fossil fuel is the main energy source. One of the unwanted byproducts from using fossil fuels is carbon dioxide, a greenhouse gas. Therefore, increasing use of fossil fuels in industry, transportation, and construction could add a large amount of carbon dioxide to the Earth. Nowadays, biomass, especially from agricultural waste, is considered to be one of the potential alternative energy resources to substitute from fossil fuels. Since it is plenty in nature, it can be converted to biofuels or thermochemical rules such as hydrothermal processing, pyrolysis, and gasification. In many countries, including Thailand, hemp or cannabis sativa is being promoted as a high-valued economic crop. Hemp is excellently agronomic in several points of view, including food, hemp proteins, pharmacy, and construction. However, after processing, about two-thirds of starting raw materials become waste. More increasingly, hemp residues may be used as a renewable material or fuel. Among these thermochemical conversions, pyrolysis would probably be a promising technology for transforming hemp residues to high-value products. Pyrolysis is endothermic process where feedstock is heated up to temperature within 400 to 650 under nitrogen limited environments to produce bio-oils and solid chars. For industrial application, a better understanding of thermochemical degradation behavior of hemp residues is necessary. Therefore, the objective of this work were to investigate reaction kinetics for pyrolysis of hemp residues and to analyze pyrolytic kinetic parameters using FWO, KAS, and Kissinger methods. The material and methods. We got a sample of hemp husks or residues from local hemp planting in Chiang Mai, Thailand. The sample was dyed under sunlight without dirt and impurity. The sample was then homogenized by a blender to a particle size of about 0.1 millimeter. The thermal chemical degradation of the hemp residue was conducted using Perkin-Elmer simultaneous thermal analyzer. In each test, we used the sample about X.5 mg nitrogen gas to maintain the pyrolytic environment at 20 mm per minute. The sample was heated up from room temperature to 1000 degrees Celsius at 10, 25, and 50 degrees Celsius per minute heating rates. In each condition, we repeated the test at least 3 times. In this recent work, model-free or isoconventional methods were used. By these models, solid-state kinetic reaction is viable to evaluate biomass pyrolysis to yield char and volatile. The pyrolysis of solid could be represented by equation 1. The thermal reaction rate equation can be shown in equation 2 with Arrhenius equation. From equation 2 with a linear heating rate, we can obtain equation 3. And equation 4 is the integrated function of equation 3, where function G alpha is the integral form of function F alpha. From equation 4, whereas integral kinetics models can be applied to analyze the kinetic parameters such as FWO method, KAS method, and Kissinger method, which can be expressed as equation 5 to 7 respectively. For now, we are in the section of result and discussion, starting with the thermal degradation behavior of HEM residues. From the figure A, increasing heating rate from 15 to 50 degrees Celsius per minute was found to shift the conversion forward by about 3 to 5 degrees Celsius. In figure B, as we expected, there were three main stages of mass loss during the pyrolysis of HEM residues. The first stage was between room temperature and 150 degrees Celsius from dehydration of moisture content in the sample. The second stage occurred from 200 to about 400 degrees Celsius, which was the main reaction, consuming about 60% weight by weight of the total mass loss. This is well known as active pyrolysis. The volatile matter in the sample is deleted. The final stage was after the temperature higher than 400 degrees Celsius. This was because the sample underwent carbonization or passive pyrolysis. As the main pyrolytic reaction occurred between 200 and 400 degrees Celsius, the main corresponding conversion from 0.2 to 0.8 were considered for the kinetic analysis of HEM residue. From figure A and B, we can see that the ligation of FWO and KAS methods fitted very well with the experimental data. The activation energy for the thermal degradation of HEM residues can be calculated from the slope of those fitting lines. Here is the linear ligation of Kissinger method. The activation energy is assumed to be constant for all the conversion of the sample. So we got only one line for the ligation. The slope of this ligation was employed to estimate the activation energy, similar to both the FWO and KAS. Here, I am going to compare the activation energy based on those three different methods. We can say that the activation energy from FWO and KAS method has the same decreasing trend with increasing conversion. The activation energy from the FWO were initially about 365 kJ per mole and decreases to 250 kJ per mole when conversion was increases from 0.2 to 0.8. The activation energy from FWO was observed to be slightly lower than for the KAS within 5 to 20 kJ per mole. The average value of the activation energy was about 286 kJ per mole. For the FWO, it was around 292 kJ per mole for the KAS. For the Kissinger, on the other hand, the activation energy exhibited a constant value of 282 kJ per mole for the entire process. It was worth noting that the average value of the activation energy from both the FWO and KAS was almost equal to the activation energy from the Kissinger method. These observations were also confirmed in the literature. For example, pyrolysis of poplar wood. Well, in conclusion, from the investigation of hemp residue pyrolysis, the thermal degradation of hemp residues occurred in 3 steps: water evaporation, passive and active pyrolysis. The main pyrolytic reaction occurred at about 200 to 400 degrees Celsius with about 60% weight by weight conversion. The pyrolysis kinetic parameter was 265 kJ per mole for FWO and 290 kJ per mole for KAS on average, as well as 280 kJ per mole for Kissinger methods. This work was supported by the National Research Council of Thailand and Chiang Mai University. Thank you for your attention. Okay, this finishes. And now I will be happy to answer. Have you have?
Professor Jean, I think you're muted.
If others don't have a question, then I have a question. Do you carry out CFD analysis of the entire happenings of those thermal activities?
Greenpeace. Okay.
I am just asking whether you carry out detailed computational fluid dynamic assessment of those things and compare the results with the actual and the experimented one. Experimented with the theoretical one.
No. It's from yes.
Okay, I have another quick question. So the biomass that you have used, the hemp residue, that's been sort of cleaned and dried and etc. But ideally, if you like to consider the commercial application, doing those sort of pre-processing will add cost to the overall production of the converted items. So did you try the outcome or the yield in the raw condition without any treatment?
No.
Oh, okay. All right. No, that's all right. Yeah, I thought I'd check with you if there's any big variation if you do it without any treatment. Any other question from anyone? Okay. If not, I would like to request you to stop sharing your screen so that the next presenter can share. Professor Jean, you're still muted.
Thank you.
Welcome. Okay, we may have a bit of technological issue, but anyway, in the interest of the time, we can probably proceed to the next presentation. Next presentation is a recorded one. So it's from Dr. Promamate Sisusan from Pio University in Thailand. So let me just open the presentation and then I'll quickly share it from my screen. Okay, I need a bit of help from Dr. Mankit because if you don't stop sharing your screen, I can't share the next presentation. So you have to stop sharing your slide.
Just a moment, please.
Yeah, no worries. Thank you.
Okay. I don't know. Okay, just a moment. Okay, stop. Okay.
Yep. Yep. All good. Yeah. Now we can share. I think let me just share the sound, and I hope you can see the screen I'm sharing. So let's start the presentation and then we can go to the Q&A.
No, I can see it's black.
Okay. Okay, just bear with me. Yeah, it's all somehow frozen, but I'm back. Give me a second. Let me share the screen again. Hopefully it will be better.
Ladies and gentlemen, I am Prapaporn Prasadpong, a lecturer from Department of Mechanical Engineering, Rajamangala University of Technology, Thanyaburi, Thailand. Today, I will present my research on densification of corn residue for producing pellet-type biomass fuel. My presentation is divided into 5 main parts. First, I will talk about background of biomass densification and the rationale of this research. Then, materials and methods. Third, results and discussion. Fourth, conclusions. And finally, recommendation for future study. Let's start with background. Continual growth in energy consumption, greenhouse gas emission, and environmental problems from combustion of fossil fuel is alarming, and it has raised sustainable energy research to be among top priorities. Agricultural residue, as the major byproduct of agriculture, is one of the most important biomass resources, with excellent energy potential and in many countries. Corn is one of the important agricultural crops in many countries. Its cultivation and harvesting provide a huge amount of corn residue that are potential biomass feedstock for fuel production. Normally, this corn residue, such as cobs, husks, leaves, and stowers, were left in the field and consequently disposed of via burning, which create air pollution that affecting human health and environment. This residue can be utilized for heat, power, and fuel production. However, the low energy density affects its storage, transportation, and uses. Densification can be applied to improve its property and enhance this utilization. Densification of corn residue has been studied by many research groups. However, for densification of corn husks or peels, which were normally attached to corn cob, had rarely been studied. Hence, study into conversion of this specific corn waste to high-quality fuel is of interest. So, the objective of this work is to study densification of corn cobs and corn husks using a pellet mill. In this study, corn cobs and corn husks were used as the raw material. They were torn off with a shredding machine, then further ground using a disc mill to obtain the particle size less than 3.0 mm. Both ground corn cobs and corn husks were dried in a solar-powered greenhouse dryer until their moisture content was reduced to about 9% dye resin. Then, the sample material were prepared for 5 different initial moisture content, by adding predetermined amount of distilled water and thoroughly mix. The pelleting process was carried out in the fat die pelletizing mill with 8 mm diameter holes and initial die temperature of 80 degrees Celsius as shown in the figure. In the typical run, 5 kg of sample was fed into the pelleting machine. Then the pellets were dried out using the solar greenhouse dryer for at least 3 days to reduce the moisture content. For property analysis of pellet, 400 grams of each dry pellet for each run were utilized. The length of the pellets was measured and classified into different ranges. The bulk density and property of the pellet type concob and conhas were analyzed. For pellet formation, concob's pellet can be successfully formed at the moisture content of 10 to 20%, while formation of conhas pellets was occurred at the moisture content of 15 to 30%. Increasing in moisture content from 10 to 20 result in increased pellet yield for both materials, while the further increase in moisture gave negative effect on the densification of conhas. For pellet length, conhas pellets were shown to have higher yields of formed pellet for all lengths at the same initial moisture content. For the pellet type concobs, the highest yield of the formed pellets and the longest pellet lengths in the range of 30 to 40 mm were found at the initial moisture content of 20%. And most of pelletization of conhas provide short length of pellet for all initial moisture content. The highest yield for the formed pellets was also found at the same initial moisture content at 20%. For bulk density, conhas pellets have higher bulk density than concob pellet. The maximum bulk density for both materials was found at the initial moisture content of 15%, which is 232 kg per cubic meter for concob's pellets and 304 kg per cubic meter for conhas pellet. For proximate analysis and heating value of pellet, it was found that pellet type conhas have slightly higher heating value than concob pellet, which higher than standard, and the moisture content for both pellet type concob and conhas are in the range of the expected value mentioned in the standard. For conclusion, concobs and conhas were successfully formed via densification at the initial moisture content in range of 15 to 20% with maximum bulk density of 304 kg per cubic meter. For recommendation, binder adding and process parameter adjusting should be studied to improve the fuel quality of pellet. This work was supported by new research grant, National Science and Technology Development Agency, Rajamangala University of Technology Thanyaburi, Chiang Mai University, and University of Phayao. Thank you for your attention.
Right. Thank you for the presentation. I think Professor Jean is back now, so I'll hand over the session to you and you can continue.
Can we move forward? Is Dr. Citizen here? Can we ask questions?
Yeah, I think, yeah.
I am a presenter of the presentation. You can ask me.
Yes. Thank you, Dr. Citizen. Thank you for your excellent speech. Anyone have any questions?
Yes, I have a question. Again, can you model from the different varieties of the corn, because it will have the different moisture content. So these uncertainties, how you can take care or how you can model that?
Do you mean like how I take care the moisture content of the biomass we stock, right?
Right.
So after we add the distilled water into the biomass, so we kept it in Ziploc bag, so it can keep the moisture content of the biomass in the expected value. And when we will run the piloting machine, we just open the Ziploc bag and add it into directly into the machine. So the moisture content of the biomass feedstock will not change much and significantly.
Thank you.
Okay, thank you for
if you have more questions, please type in chat box. I think we will move forward. We'll invite welcome Dr. Nigran Homdog from Mayo University. Dr. Homdog, welcome.
Okay. Good morning. I want to share the screen. Are you see?
No.
Are you see the screen?
It's loading.
Are you see?
Yes, this is.
Okay.
I can see it.
Okay. Good morning, Chairman and Professor and all researchers in this room. My name is Nigran Homdog. I come from Mayo University, Chiang, Thailand. Today, I would like to present my product of the pattern is the product of the purified bacteria in a rotating bed thermal reactor. The outline of my present consists of the introduction, objective, material and the method, result and discussion and conclusion. Introduction, position of agricultural residue in Thailand. Thailand is an agro industry. Thailand is an agro industrial. Oil palm and corn crop are economic crop that generate income the farmer in the Thailand. The slide show the area of the grow the corn and the oil palm. The corns are grow in more in the northern and the central of the Thailand. While the oil palm are grow more in the southern and the eastern of the Thailand. For about the agricultural residue in Thailand in each year, the oil palm of about the 1 million tons per year, and the corn is about 23 million tons per year. Because Thailand is more agricultural residue, so we are to focus on the different development of the biomass into the energy for use in the industrial sector. The technology we are using in the desiccation with the torrefaction process for take about 35 biomass pellets. The objective is reduce the fuel import for the overseas. Importantly, they reduce about to the carbon dioxide and cause in the global warming in the world. The all data is researched in this work. The objective and the overview of the research. The research was focused on the analysis of the chemical and physical property of the purified biomass pellets with using a rotating bed thermal reactor. For the overview of the research, we are taking the cost grading, site selection, the torrefaction process, and pelleting and drying. After that, analysis of the chemical and physical property of the torrefied biomass pellets. The material and the method. This slide shows about to the rotating bed thermal reactor. The volume of the reactor of about 280 liters. We are use nitrogen to in the carrier gas and use about to the cooking gas for to the generate heat in the system. In the table show about the process in the production of the torrefied biomass pellet consists of the coarse grinding, fine grinding, torrefaction, and pelleting. This slide shows the equipment and instrument for use in the research. Consists of the biomass reduction, biomass pellet machine, 5 robot stove for use in the optimal analysis, digital scale, and okay. For in the table show about to the electrical energy power for use in the equipment and the instrument. This slide show the biomass preparation and test procedure. This slide show in the oil palm front and to the concord for use in the research. And the right slide show the table of the chemical property in raw material of the oil palm front and the concord. We are to analyze in the approximate analysis and the ultimate analysis and heating value and boundary. For about the temperature for use in the torrefaction in the oil palm front and concord, we are use the temperature up to the 200 Celsius. And resident time for in oil palm, we are use about to the 40 minutes, and the concord we are use in the 20 minutes. We saw and discussion the chemical property of the torrefied biomass pellets. This slide shows the approximate analysis of the raw material, torrefied biomass and torrefied biomass pellet. We have found that about to the moisture and the volatile were decreased will the free carbon and ash is increased. Moisture and volatile is decreased, and a free carbon and ash is increased. It's vary about torrefied biomass and torrefied biomass the pellets. The reducing of to the moisture and increasing of the free carbon less to the good combustion. This slide shows the heating value of the oil palm front and the concord. We have found that about to the torrefied biomass pellet is higher heating value in the process. The oil palm has a higher than the heating value which compare the Concord. The maximum the heating value in the oil palm about 23 megajoule per kilogram. Will the Concord have of the 20 megajoule per kilogram. This ratio the physical property of the purified biomass pellets in the color and shape of the raw material and purified biomass pellets. For two color, oil palm front start form in the white brown and the dark brown. And for two the Concord start form in the light yellow and the bright brown. In the table in the bottom show about the property of a physical property of to the purified biomass pellets consists of the density, shatter index, water resistance, and the compressive strength. The all parameter in is higher than standard. For to the density is higher than the 600 kilogram per cubic meter, and shatter index and water resistance is higher than about to the 90%. This slide shows the critical energy consumption. We have found that the torrefaction process have the highest electric energy consumption. Next is pirouetting and cross guiding respectively, and the maximum electrical energy consumption was occurred in the oil palm front is 80 kilowatt-hour per ton. Will the Concord is 50 kilowatt-hour per ton. This slide shows the thermal energy consumption of the oil palm front and the Concord in the torrefaction process. We have found that about in the oil palm front use the thermal energy consumption of the 4 gigajoules per ton, and Concord of 3.3 gigajoules per ton. Conclusion. The moisture and the volatile will decrease after torrefaction and pirouetting process. Will the free carbon and ash which increase? The heating value of to the Concord and oil palm front in the torrefaction process with pirouetting was increased about to the 30%, and that's calculate the heating value between the 20 to the 23 megajoule per kilogram. The physical property of to the torrefied biomass pellets was higher than standard, and the torrefaction process was high as electrical and thermal energy. The use of oil palm front was higher than electrical and thermal energy with compared Concord. Acknowledgement. We would like to thank National Research Council of Thailand, the Office of Agricultural Research and Extension Major University, Thailand Science Research and Innovation, School of Renewable Energy Major University, Energy Research Center, and Chiang Mai University for support the budget and the equipment of. Thank you for your attention.
Thank you. Thank you, Dr. Hong Dong. Any questions? We have several minutes left. I think we can ask some questions. Dr. Hong Dong, are you here?
Okay.
Yeah, I'll probably ask a quick question. So the biomass that you have considered to make the pellet, how do you evaluate the availability of that for commercial scale operation? So is it like a seasonal waste coming from the agricultural area, or it's something that can be available on a continuous basis for sort of commercial production and processing?
Okay, okay.
Do you want me to repeat the question?
Again, a question. Again.
Okay, I'm just thinking about the biomass that you have considered, how available that biomass for commercial sort of processing. Is it widely available in Thailand or in Bangkok? It's all right if you are. This is not a critical question. I just thought that I checked the availability. That's fine. No worries. Thank you.
Thank you. Thank you, Dr. Hondo.
Okay. Thank you. Okay,
Thank you.
I talk with in your email. I talk with email. Okay.
Sure.
Okay.
No worries. Thank you.
Thank you, Professor.
Thank you.
Yeah.
And I think next we'll welcome Dr. David Gruff from Karlsruhe Institute of Technology from Germany. Welcome.
Good morning. I will share my book. I hope you can hear me loud and clear so far. Is my audio okay?
Okay.
It's okay. Now I should see my screen, right?
Yeah, we can see your slides.
Oh, okay. Okay, so hello again. Yeah, my name is David Graf. I'm from the Karlsruhe Institute of Technology. And yeah, today's presentation is on the production of lower metabolite blending components like ICEP processing a heavy biomass-based gasoline. Some information on the background and motivation. So in the European Union, we decided to be greenhouse gas neutral by 2050 and shape this in the so-called Green Deal. When we take a look, for example, Germany, there the transportation accounts for about 80% of the greenhouse gas emissions. In contrast to that, last year we had just 6.7 newly registered fully electric-driven cars. So that means the other 93% still rely on an internal combustion engine. Additionally, the average lifetime of the car is up to 18 years. In Germany, we call it 10 years. That means the next decades we definitely have to deal with such cars which rely on an internal combustion engine. That's why we addressed this question in our working group and consider a so-called green refinery concept. In the green refinery, we use the Fischer-Tropsch synthesis for providing kerosene and diesel, and we use the so-called methyl ether to gasoline route for providing gasoline, the DDG synthesis. In Karlsruhe, we have such a plant, the pilot plant, which uses the decentral fast pyrolysis, where we pyrolyze biomass to obtain a slurry, which is then in a central facility gasified and further processed in a DDG synthesis for providing gasoline. In this presentation, I don't want to focus on the whole thing, just on the so-called hydroprocessing. That's an upgrading process where we want to make our gasoline standard conform. So why do we upgrade our gasoline? How does it look like? So when it comes to BTG gasoline, also MTG gasoline, those gasolines are rich in aromatics. Basically, aromatics are fine since they provide us a good anti-knocking property. So of the K number, I think you might have heard of. But the problem is the cetyl aromatics, they contain a large number of toluene. So toluene, as you can see, is a highly symmetrical molecule, and that means it tends to crystallize. So when temperature cools down, we will find our product in the solid phase, and yeah, this can cause obviously energy damage. So we had to somehow deal with that. We decided to distillate our product, and we obtained about 2/3 of the so-called light gasoline and 1/3 of the so-called heavy gasoline. And the idea now is to take this heavy gasoline and upgrade it and blend it back into the light gasoline. Now we have to think of how should we upgrade the heavy gasoline. For this, we need to take a look on the quality of the light gasoline. So here you can see the boiling characteristics. Our light gasoline is the orange dotted line. A standard conform gasoline, as you can get it at the gas stations, blue dotted line, that's the first. The yellow bars indicate the range where the gasoline should be when it comes to our standard. In Germany, we have the DEN 228. It just defines where the gasoline has to be. And there you can see there's a huge gap between the orange dotted line and the blue dotted line. In other words, our gasoline is way too heavy. So we somehow need to find some light boilers here. So to push down this orange line so we can be near the blue dotted line. For this process, we decided to run a hybrid process here. So how does this process look like? So here you can see different molecules. The number indicates the octane number. The first step, our aromatics step hydrogenated. And there you can see already a drop in the octane number. That's a bad thing since we want to blend back our upgraded gasoline. That means the octane number of the whole product will drop. So we consider a second reaction step, which is the isomerization. But there you can already see that octane numbers widely differ. So from that we can tell, okay, the catalyst selectivity somehow plays an important role. And then we can further push this reaction to form paraffins by using a ring opening. But this doesn't make it much easier since the number of isomers even increases further. We can say from left to right, definitely the boiling temperature will lower. That's what we want. For this, we use platinum zeolite, for example, acetylene 5. Platinum because it has a high hydrogenation activity. Zeolites because, as you might know, they are quite good when it comes to shape selectivity. And because of the ASEP, they are also good for ionization reaction. We did a parameter variation at all of our catalysts, and on this we run fixed bed reactor in our lab. The fixed bed reactor is fed with our liquid and the hydrogen on the top of the reactor. And later we have a separator where we get our liquid product. The liquid product is analyzed offline according to the valid standard here in Germany. And when it comes to the gas phase is analyzed online for calculating the mass. So how did the results look like? Here you can see the E150 and the E70 plotted against the mass yield. Just as a reminder, E150 means volume evaporated at 150 degrees Celsius. So we are talking about light boilers here. And the E70 is even larger. So overall, we can see a sharp rise for the E150. And this is mainly due to hydrogenation reactions. So here we have the hydrogenation of heavy alcohols. When it comes to E70, you see something different. It is rising slowly for high molecule and increases sharply for low molecule. And this is mainly due to cracking reactions. And here we found mainly the so-called pairing reaction. When the current reaction is occurring, that means that the metal groups in our rings rearrange and then get chopped off, forming mostly butane. That's not too favorable since butane is not really in the gasoline range. So we can tell that somehow trade off. Of course, we want those light boilers, right? But we can go too deep, otherwise we won't be economical. Then I told you that the octane number somehow is important to us, because we want to blend back the gasoline. And here we found also that the catalyst plays an important role, especially for the motor octane number, which is the octane number at a high load, for example, on highway. And there we found, for example, that H75 worked out quite well. The overall increase we could explain here an increase in the isotherapy, which you can see here. When it comes to lower mass yield, we will see an increase in the paraffins, and that's mostly due to the ring opening and also the pairing reaction. So when it comes to conclusion, we can tell hydroprocessing is definitely suitable for improving our petrochemical parameters, and also we could achieve overall better C balance. That's because we can backmix that heavy gasoline, which was before was just a waste we couldn't use. Some additional information, something I didn't admit to the ICEP. Of course, we did some blending experiments, and the green dotted line showed such a blend. This blend had a renewable share of about 85%, and the gray dotted line shows a standard shell gasoline, and there you can see we're quite near that line. As a reminder, the blue dotted line was our original gasoline. So this is definitely suitable for supplying standard platform gasolines. And we have also some engine tests going on in the automobile industry. As a brief outlook, we also do some modeling. Keyword is the US index, which we try to predict using artificial intelligence. And of course, we also do some techno-economic assessment, also alternative process law. Yeah, that's it for my presentation. Thank you for your attention. If you have any questions, feel free to ask or contact me using the provided. Thank you.
Thank you, Dr. David Groff. Any questions?
Can I have a quick question, please?
Sure.
Hello, David. Could you let us know whether your catalyst is commercial one or the one that you synthesize in your lab?
Oh, that's a good question. So since our project is really near to the industry, that was one of our it was defined to use a commercial catalyst. So we had no chance to do our own catalyst. We used only commercial one. So the step to do the actual process is not too far.
Okay.
And maybe
could you also comment on what happened after your hydroprocessing? What happened to the catalyst? Is still okay, or have you seen some poisoning or deactivation effects at all?
Oh, I think that's also a good question. That depended highly on the catalyst. Mostly the acidity I found has a large effect on that. But those research is still ongoing, but I can tell that, for example, the H75 was quite stable, and we ran it for like, was on stream, I would say, over 100 hours. And yeah, it was not that much deactivation in there. But when it comes to modern night, we had a large deactivation.
Thank you.
Yeah.
If we don't have more questions, I think we can move forward. Let's welcome Dr. Kitkorn Sathajit from Male University, Thailand. Welcome.
Yes. Good morning, ladies and gentlemen, and Professor Charles Horry and Professor James. It's my pleasure being here today. My name is Kitikon Sathajit. I'm from Metro University, Chiang Mai, Thailand. And now I would like to my presentation, my work on the experimental investigation of the gasification of densified agricultural biomass in the Daldap gasifier. Here is the outline. My works. First, I will talk about biomass conversion and biomass densification, and then experimental setup and the procedure, and finally, conclusion of this study. Biomass is organic matter from the nature. For example, wood from tree, wood from factory, and agricultural waste. Thailand is an agricultural country with significant biomass potential. According to some study, biomass waste might be up to 15% of the energy demand in Thailand. And the major biomass resource in the Thailand includes the following: woody biomass residue and agricultural residue, and the livestock manure and the municipal solid waste. The densification process is critical for producing a feedstock material suitable as a commodity product. There are numerous advantages to densification. First, improved handling and conveyance efficiency. And the second, controlled particle size distribution for the improved feedstock uniformity and the density. And the third, component of the structure were fractionated to improve their compositional quality using a predetermined conversion process. In general, the biomass conversion technology can be divided into the three processes. First, the physical chemical conversion such as biodiesel production. And the second, the biochemical conversion such as anaerobic digestion and hydrolysis and fermentation. And the third, thermochemical conversion such as the pyrolysis, gasification, and combustion. The major methods of the thermal conversion process are the combustion in the excess air, gasification in the reduced air, and the pyrolysis in the absent air. In this work, we are interested in the biomass gasification process. This is the conversion of the solid or liquid feedstock into the useful and the convenient gas, fuel, or the chemical feedstock. And that can be burned to release energy or the use for production of the value-added chemical. The main component of the producer gas consists of the carbon monoxide, hydrogen, and some methane gas. It has a low heating value about 4 to 7 megajoule per cubic meter for air gasification. The purpose of this study is to investigate and densify agricultural biomass gasification in a Daldap gasifier. And they examined to the composition of the producer gas, and the producer gas yield, and the coal gas efficiency, and the low heating value, and the tar content from gasification process. Agricultural waste for this study use lighthouse, oil palm fronds, corn cob, and wood it had a low heating value about 12 to 16 megajoule per kilogram, and about density of around 600 to 700 kilogram per cubic meter for the briquette biomass. And the pellets biomass show the bound density higher than 1,100 kilogram per cubic meter. This slide will show, this slide will show the CPT diagram our experimental setup. We have 50 kilowatt hour DAP gasifier, and the gas cleaning system consists of the cyclone, gas cooling, and the venturi waste scrubber units, and the filter. The data sampling units was collected from the raw producer gas and analysis by gravimetric method. Next, here are the results of this study. The diameter of the briquette biomass is 50 to 55 millimeter, and the length around 20 to 35 millimeter. And the diameter of the pellets biomass is 5 to 6 millimeter, and the length is 20 to 30 millimeter. Next, this slide to show the fuel consumption rate and the low heating value of the producer gas from the DAP gasification. It was found that the fuel consumption rate of the briquette biomass around 6 to 14 kilogram per hour, and by using pellets biomass around 9 to 14 kilogram per hour. And the low heating value of the producer gas from biomass gasification show low heating around 3 to 4 megajoule per cubic meter. And next, this slide will show the effect of the biomass densify on the coal gas efficiency and the producer gas yield. It was found that the coal gas efficiency by using a briquette biomass show around 57 to 68%, and by using a pellets biomass show around 61 to 73%. And the producer gas yield was found 2 and 3 cubic meter gas per kilogram fuel. And next, we biomass tar content from the gasification with the briquette and the pellets biomass. It was found that the tar contents by using a biomass briquette biomass show around 33 to 45 gram per cubic meter. And so we use the pellets biomass. The tar content show around 17 to 28 gram per cubic meter. Now I would like to conclusion. It was found that the biomass densified into the briquette and the pellets was declared to be an excellent raw material for the gasification. And the average fuel consumption rate, a different biomass briquette, was around 6 to 14 kilogram per hour. And by using a biomass pellet in the range of 9 to 14 kilogram per hour. And so the producer gas has a low heating value around 3 to 4 megajoule per cubic meter. The maximum coal gas efficiency show around 73% by using the wood chip pellets. The biomass content in the raw producer gas was show the higher than allowable limit when an internal combustion engine was used. This study showed that it is possible to use identified biomass for the gasification process and application for the electric power generation. This work was supported by the National Research Council of Thailand, Chiang University, and Metro University. And thank you for your attention. Have any question?
Thank you. Thank you, Dr. Kitikron Sasujit. Thank you very much. Any questions?
I have a quick question. So what do you do with the tar that you are getting? Is there any subsequent process you go through to get the yield from the tar?
Oh, right. Sorry, wait. Okay.
Yeah, so in one of the slides you mentioned you are getting quite a large portion of tar. So what do you do with that tar? Do you do some further processing? Yeah.
Okay. Please question again. Sorry.
No, that's all right. No, my question is, so you mentioned here that about 33 to 45 gram per cubic meter is the tar content. So do you do any hydro treatment or anything with this tar? So what do you do with the tar from here?
Oh, yes. The tar content from the biomass densified in of this study and show the higher limits. But the future my works for the application for the cleaning system with the better tar for removal efficiency and by the crack by the crack cleaning because the several research have a limit contaminant of tar from the gasification for use in the internal combustion engine for for power generation. Researchers who suggestion the tar have a content about 50 to 100 milligram per cubic meter, but this study we are sampling with the raw producer gas, but sampling with after treatment. And the next picture we check the after treatment of the tar content from the from after treatment.
Okay, no, thank you.
Any other questions? If there's no question anymore, I think we can stop here. I'm very honored to be chairwoman of this session, and I would like to thank Professor Feroz Alam and thanks thanks goes to Dr. Asfik Chowdhury and all speakers gave very excellent speeches today. Thank you all.
Yeah, thank you everyone, and thank you Jean and the organizing committee for the sessions. It was good to hear some of the work doing by researchers around the world. So I appreciate their time and the effort. Thank you.
Thank you.
Thanks a lot. Thanks a lot, everyone, and particularly our participants, those who listen carefully and also presented, as well as our session chair and co-chair. Thank you again for all of you, and have a nice time. And also those who can attend the next session. Thank you. Bye.
Thank you. Bye. See you.